What's up, I'm Troubleshoot. In this first episode, quick start guide, I'll be showing you how to pick a Linux distribution, download and install it, and get some basic things done on it. Whether you're working on physical hardware like me, or you're using a virtual private server, or something like that, over the internet. This little box I'll be installing Linux on, setting up a remote connection to it, and I'll be turning it into sort of a storage box / media server, and I'll be taking you through the same steps that I'm following, so you can get going from scratch, setting up your own Linux server, or maybe if you've already got one, learning a few things along the way. First of all though, let's talk distributions. There's many different flavors of Linux, all the way from the most controllable kinds like Arch Linux to the most user-friendly kinds like Ubuntu. Essentially, all Linux versions and distros work pretty much exactly the same. You can run mostly the same programs on all of them. The only real difference is how it looks to the user, different commands that you might be using, or different flavors of those commands. And of course, the most important thing, user support, community forums, videos just like this one, and even more. As this may be your first server that you're ever setting up, I'll be using the most simple and most widely supported distribution of Linux, which is simply just Debian. Debian is what things like Ubuntu are built on top of, so everything you can do there, you can do here as well. Keep in mind, if you're going to be using your VPS or physical hardware connected to a monitor, you might want to use something a bit more pre-made like Ubuntu, where there's tons of different web browsers and things like that built in already. But as this is just going to be running a couple of different web servers for me and other services like that, I'm not going to be using it with a screen attached, so I'll personally be doing a headless installation, meaning I don't need a display connected to this thing in order to use it and use services from it. If you have a graphics card in your device, odds are it'll work perfectly fine even without a screen attached. If anything, you could get yourself a dummy HDMI plug just to stick in it so it thinks it has a monitor attached, and that fixes pretty much any issues that you could be experiencing. So now that we know what distribution I'll be using and hopefully what distribution you'll be using, let's start from the very top in a pretty broad way, just so you can follow along with no matter what you're downloading. Whether it's Arch Linux, Manjaro, Ubuntu, Debian, Mint, anything like that, the steps should be pretty much exactly the same. First of all, we'll need to download the ISO file, which is a disk file, and burn it to USB, meaning copy it out and extract it to a USB so that we can boot to it on a device like this and install our operating system. As this is a Linux-centric guide, I'll be showing you how to burn onto USB using Balena Etcher, but linked down below, you'll find guides for Windows as well, as the steps should be mostly the same. So let's get into it. Alright, so I'm heading across to our system. The first thing we want to do is make sure that our USB is empty. Once you've got your USB plugged into your system, you can open up a file browser and see what's on it. Essentially, we'll need to clear everything off of your USB drive, as it'll be completely written over with our installation medium. Whether you're installing Ubuntu, Debian, Arch Linux, or anything like that, you'll need a fresh USB drive that we either install something like Ventoy, where we can just drop ISOs, such as the Windows 10, 11 ISOs, and things like that, or we'll be overriding everything on the drive with our installation media. As there's nothing important on this drive, I can happily override everything on it with whatever operating system I'd like to install. So with that out of the way, let's actually download our Linux operating system of choice. I'll be using Debian. There's thousands of things that we can install, and you can choose to install different desktop environments or even no desktop environment at all if you're going to be running it as a completely headless remote server like a VPS on the internet. That's what I'll be doing here. I'm using Debian as it's super lightweight, and of course it's super popular, meaning there's tons of things that I can run on it, and there's really good support for it. In order to download it, just search Google for download space whatever operating system you're trying to run. So Ubuntu, Arch, Debian, etc. Then head across to their respective website and download however necessary. So for example, Ubuntu Desktop is super simple. You just choose a version and you choose download. Arch Linux is a little bit more confusing in that there's a BitTorrent download at the very top, and scrolling all the way down, you'll eventually see different mirrors we can download this from. Linux distros are very different to Windows in that there's thousands of places that we can get them, not just Microsoft. Mirrors are different download sources and hosts in different countries, so look for the one that's closest to you. The same is to be said about Debian. If I choose download mirrors here, you'll see all of the different places we can download Debian from. If I choose the closest one to me, which will be South Africa, we get a bunch of different versions here, including the current version. I'll be downloading current live, the latest, most up-to-date version. Then you'll need to choose whatever architecture your system is, in my case, AMD 64. For most PCs and mini PCs, NUCs, etc., it'll all be running AMD 64, as it's just the go-to standard. A much lower powered, newer version would be ARM, which runs on things like Raspberry Pis, Android devices, etc. Then choose how you'd like to actually download it, in which case it'll mostly be ISOs, ISO CD, ISO DVD, something along those lines. For this, it's ISO hybrid. Then finally, you'll actually get to your download. Sometimes it's more than one, sometimes it's only one. Here we have the same version for everything, but we have Cinnamon, GNOME, KDE, LXDE, LXQT, Mate, and XFCE, as well as Standard. All of these are different desktop environments. So for example, Linux Cinnamon is what Linux Mint runs on, and it looks something like this. GNOME looks more like this, KDE like this, LXDE like this, LXQT looks more like this, Mate like this, and finally XFCE like this. For the most part, they're all functionally exactly the same, they just look a bit different and have different animations, etc. You'll only really find out how these different things look by Googling for them or just having a baseline understanding of what they are. These usually come around 3 to 4 gigs in file size, pretty much for most operating systems, especially Debian-based ones. But if you're like me and you're only going to be running command line programs here, such as Docker and things like that, you can download the headless version, which comes without a graphic user interface, called just Standard in Debian's case. It's half the file size and should be a lot lighter to run, especially on older systems, but of course, you can't run anything that requires a window, like games, etc., or at least for the most part. You can always install a desktop environment later on, or change between them if you wish, although the commands for which are usually a bit confusing and can end up making things a little bit worse on your system until you end up troubleshooting through them. So, as I'm comfortable using a CLI-only version of Debian, I'll be downloading the standard ISO here. Once this file downloads, we need a way to actually get it onto our USB. On Windows, I've used programs like Rufus, but on Linux, the go-to burner for USBs is Balena Etcher. You'll find a link to this down below. Simply select the image, select the drive, flash, and that's it. If we choose Download Etcher here, it takes us to download for Windows, Mac, and Linux. The Linux version is a zip and is a little bit confusing. For the most part, you can find Balena Etcher in your operating system's app store, which is going to result in a much simpler installation method. If you'd still like to manually install it, for things like Debian and Red Hat, they do have packages here. Ubuntu is based on Debian, and as I'm currently using Ubuntu, that's what I'll be using. So I'll click this link here. For your OS, there may be slightly different steps in order to actually install this. When we click this link at the bottom, it takes us to the Balena Etcher GitHub page, where it goes through the installation process for Debian and Ubuntu, Red Hat, Arch or Manjaro, Windows, and that's pretty much it. As we're covering the Debian and Ubuntu packages, it's essentially just download the latest version from the GitHub release page and run this command here. So, heading across to the release page linked here, all we need to do is find the latest version .deb, standing for Debian, and that's over here. We'll click this and download it. After 100 megs is done downloading, you can either click on it if it says something like Package Manager, but if it opens up like a zip, it's not going to install that easily. We'll instead need to open the folder, then right-click anywhere and choose Open in Terminal. Now we can run some commands in our download folder. The command that we need to run, mentioned previously, is sudo apt install space followed by the file name. So Ctrl-Shift-V to paste that in. I'll then hit space and I'll hit / followed by tab to list files in our directory. As you can see, Balena Etcher is listed here. I'll drag around it to select it, right-click and copy to copy, and finally right-click paste or Ctrl-Shift-V to paste. Once we've done this, we can actually get to installing Balena Etcher. I'll enter my password, and shortly after confirming things, it should be installed and set up on our system. At this point, you can just search for it in your start menu, and if you find it, you can open it. However, if you run into an error like this where it says _app doesn't have permission to access this file here, you'll simply need to move it to a different location. So I'll copy the name of the file and we'll type in sudo mv space the file name, and we'll move it to somewhere that everything can access, such as /opt. Once we do this, cd into opt and ls, you can now see the file here. Once again, we'll run the install command, which was sudo apt install followed by the name of the file, and this time things should work a bit better. Now that it's done, we can actually open up Balena Etcher and get to burning it to our USB. So first of all, we'll flash from a file. This file is in my downloads folder as Debian Live. We'll open this, and now we need to choose a target. I'll select my USB drive, which we've already taken everything off. Once we've done this, choose flash, and just like that, after entering our password, our USB drive is emptied out, and the operating system of our choice is put onto it. With this, we can boot into it, test the environment, and more importantly, reinstall our operating system. You can burn anything to your USB, whether it's Ventoy, Debian, Arch Linux, or even a Windows install, so that we can boot our system into it and get things going from there. We'll wait for this to finish, and once it has, it'll verify, which is a fantastic feature of this program, that everything is correct the way that it should be, and once it's done, we can now reboot to this USB drive and install our new operating system. So all that's left to do is to reboot our system and spam F2, F12, delete, or whatever key it is in our current system to boot to the USB drive, or go to the BIOS and choose where we want to boot from. So with that, let's restart, or power off and press the power button. Spamming F2, F12, and delete should get us to the correct place, and if you happen to miss it or would like to reboot to it using a command, you can actually do so from the terminal using the command sudo systemctl reboot space followed by 2 hyphens firmware. By running this, it should reboot straight to the BIOS screen, which is a fantastic little shortcut. This should work on most Linux OSs. So now we're in our operating system options, and all we need to do is find the boot tab or something similar, boot sequence in this case, and choose to boot from our USB first. So I'll move it up the list, the other partition up the list, and that's it, apply. So after we've saved our changes and rebooted, yours will obviously look very different to mine. It should boot to the USB, and we can choose to test out the environment and of course install it. So there we go, we've gone to the boot menu. I'll choose to use the installer rather than testing it, and after it prepares itself, we'll just need to click through the installer as we would any other OS. So English in my case, location, South Africa, keyboard, works fine. It'll detect our drives, prepare, we'll configure our network, and after internet is found, it can download updates and things like that. Now I'll need to enter a hostname for the system. We can call it anything. I'll call it NUC. Entering a domain name if you're going to be hosting a website is super important, but for me, I'll just leave it as NUC, as that's good enough to be identified on my home network. You can always change these things later. Then the admin password, make sure this is super strong and not guessable. We'll enter a user account, so in my case it'll be Techno, good enough. Yep, enter a user password, which should be different, but it can be the same as your root password, and now that things are configured, we can sort out which drive it's going to install to. So for me, I'll use the entire disk instead of just a partition, select my entire SSD or whatever drive we're going to be installing it on, and with that, everything should be erased and set up from scratch. I'll leave everything as one partition, but if you choose, you can set your /home as a different partition, which may make backing up or reinstalling a little bit easier. It just means that certain partitions may run out of space before other ones, so your home directory gets most of the space, and your OS gets only really what it needs, plus a bit extra. You may need to resize these partitions later, which is why having everything on one partition is usually the easiest thing to do and recommended for most beginners. I'll choose that and finish. If you choose to separate things, you may be required to name the different partitions, which will help you recognize them later on. With that, we'll write our changes to the disk, continue, and wait for it to partition our drive. This wipes all of the data on it, so of course make sure that when you're installing an operating system, you have everything backed up from the system you're coming from, whether it's Windows, a different Linux distro, etc. Now it's actually installing our system, which should take a little bit of time. Of course, depending on the speed of your drive and of course your USB, a network mirror. You would usually choose yes to using a mirror, but for me I fumbled it and misclicked, so I'll need to do that later on with a command I'll show you in just a bit. But for now, the installation is complete and we can reboot, and upon rebooting we can unplug our USB and use the thing as usual, now on our brand new OS. So we'll boot to Debian GNU Linux, and just like that, our system is set up, although it's very tiny. Even though everything's super tiny, it's basically asking me for my username, so I'll enter tcno, password for it, and there we go, we're now logged in. If you're like me and everything's way too tiny, as this isn't something with a desktop interface, we'll need to change it from the boot file. So we'll enter su to change to the root account, and we'll type in sudo nano /etc/default/grub grub, you'll now see a file like this open up. I've zoomed in post just to make things a bit easier. Look for the grub command line Linux default and add here no mode set as such. Then at the very bottom of the file, on a new line, add, in all caps, grub_gfx payload underscore Linux equals, followed by your resolution. I'll be going for 1920 by 1080 as such. Then hit Ctrl S to save and Ctrl X to close. Now we'll need to run sudo update -grub to save our new changes and actually write them to our boot options. And now we'll just need to reboot our system. So I'll use reboot now or sudo reboot now. Once it does reboot, things are a lot more readable. That's it. Obviously, if you're running a system with a graphic user interface, such as just plain old Ubuntu or something like that, that step isn't really required. You can change everything from your settings, things should be scaled properly, etc. This is just particularly for a command line based headless server. If you are running something like that and preparing to use this from afar or from other PCs on the network, you'll need to set up SSH as well. So for this, we'll change to our root user and run sudo apt update. And you can see that because we didn't choose any mirrors, things got a bit confused here. If we use apt -edit -sources, it tells us that we're trying to read from a CD drive. That's it. We can't update in any other way. In this same file, simply running that command, I'll change this text to rather be, keeping this last bit, https://deb.debian.org/debian as such. We'll save this using Ctrl S and Ctrl X to close. Now when we run sudo apt update, things should just work properly and super quickly, as this is a CDN powered by Fastly. If we run sudo apt upgrade, that works too. So in order to set up SSH on our system, we'll use the command sudo apt update to update our package list first, then we'll sudo apt install OpenSSH-server. We'll confirm this, then we'll use sudo systemctl status SSH to see if it's running, which it should be. If it's not, use sudo systemctl enable SSH and sudo service SSH start for our SSH to actually start up. Finally now, we'll need to see how we can access our system now that we've got SSH turned on, and we can do that with IP space A. This tells us all of our different network adapters, and as you can see, our current IP address is 192.168.1.194, just under my Ethernet adapter there, number 2. So with that number in mind, I'll just need to try and connect to it on a different system. So on my Windows PC here, I'll open up a new terminal and we'll run the command SSH space our username, which was techno at, followed by our IP address 192.168.1.194. After we do this, it'll try and connect. I'll confirm that this fingerprint is okay. By typing yes fully, we'll enter our password, and just like that, we're now logged into our system. If we sudo apt install neofetch, for example, we can get some info about our system. But as you can see, techno is not in the sudoers file, as we haven't set this up properly just yet. So in order to allow our account to use the sudo command instead of needing to switch to the root account, we'll need to first switch to the root account, use the command su space hyphen, type in your root password, and now we'll need to run the command usermod space -a space -G space the group we want to add to our username, so in this case sudo, and our username, which is just techno. After we do this, and su to swap user back to our normal user, we can now use the command sudo as we have permission. So clear, we'll change back to our user folder, and we'll run sudo apt install neofetch, our password, and it should now install properly. When we run the command neofetch, it tells us about our system, and if I look back to my actual device and run neofetch here, it'll tell us about our system as it's installed through this other shell, and it should be exactly the same because it's the same system. We've successfully remotely accessed it and got into it. At this point, you can comfortably leave your PC somewhere and remotely control it on the same local network, but of course we do want to do things like hardening our SSH, using key-based authentication and things like that, but we want to make sure that our IP address doesn't change, which we can either do from our router or by telling our network adapter to only use one particular IP address just so we can find it on the network later on. Just keep in mind that if you gave your device a name, such as nuck, we can use ping nuck, and it should resolve on our network, so we can just use SSH username at nuck, for example, instead of using this IP address here, or we can set a static IP anyways. We'll use IP space -CA to get info about all of our network adapters, nice and colored, And you can see the one that says state up is how we're connected to the internet, ENP2S0. You can see it's using 192.168.1.194 as its current IP address, and all that we need now is our router's address, which we can get by using IP space R. As you can see, default via 192.168.1.1 is our router's address or our gateway address. In order to make these things static and not changing, we'll need to change them in a text file. So in a new SSH window, just so we have all of our information handy, I'll use the command sudo nano etc network interfaces. As such, here we'll need to change some things. First of all, we'll comment allow hot plug and the iface commands over here. You can leave the IPv6 one set as auto if you wish to use IPv6, or comment it out completely to not use it at all. Then we'll use the commands auto followed by your device's name, so ENP2S0 in my case, and iface, the device's name, inet static instead of DHCP, and we can manually configure each option. So address will be 192.168.1.194 in my case, as that's what it's currently configured to be, and I'm fine with it staying as such. Then net mask should be 255.255.255.0. The gateway will be our router's address, so in my case 192.168.1.1, which is what we got from the IPR command, 192.168.1.1. Then our DNS domain will be the name of our device. In my case, I set it to NUC earlier. And finally, DNS name servers will be how we connect to the internet. First of all, it'll be your router, so 192.168.1.1. Then you can use things like Google, so 8888, or Cloudflare 1111. Saving this, we're done. We've set our static network address, netmask gateway, DNS domain name, and DNS name servers. Make sure you spelled everything correctly, me especially. Save it using Ctrl-S and close it using Ctrl-X. Now we can use sudo systemctl restart networking.service in order to restart our networking. If you're using SSH currently, it'll drop for a moment and then come back. We can check our IP once more with IPA. As such, as you can see, it's 194. We can change this to be, let's say, 195 instead, and when we restart, we should no longer be connected to the device until we punch in that new address. So I'll use SSH techno at 192.168.1.195, which we set it to. We'll trust it, and there we go. We're now connected to our new system on the new network address, IPCA. That's how we connected, 192.168.1.195. That's it. We've now got a static IP address, so we can always access it, a domain name, so we can access it easily on the network using our router's DNS, and everything's set up so you can use your brand new server anywhere on your local network. It'll keep the same address, and it should be running pretty much always. As soon as you start it up after a power outage, SSH should be enabled, and you don't even need a monitor to control it anymore. That's it. So, hopefully you found this video useful. Thank you for watching. Mine's been Troubleshoot, and I'll see you all next time. Ciao.